Welcome back, trippers. So the day has come that we needed to change our current Powerwall setup and how our packs are configured so that we can make it suitable for 48 volts. Currently what we've got is we've got 20S 32P. Now what I'll do is I'll quickly show you through what we've just kind of quickly got here on the wall. We've got two banks of 20 cells, of 20 packs, and each of those packs has around 32 cells. So this bank here, which is 20S, has got 32 cells in it. This one here is using lower capacity cells, the one on the left hand side to you, and that has got slightly more cells per pack than this one here. So this one here is all 2000 milliamp hours and above. So what that means is we've got two banks of around 5.5 kilowatt hours, and we've got those paralleled together to give us around 10 kilowatt hours, which is closer to 11. It really just depends on how quickly you drain it. But either way, we've got two banks set up. What we're going to do today is we're just going to focus on reorganizing the first set, which is pretty much my good set. So anything that's 2000 milliamp hours and above. So pretty much this pack we're going to reorganize so that we can make it suitable for 48 volts, because obviously with the pack sizes how they are, which is 32P, it's just not going to be good enough for 48 volts and what we're trying to do in the battery box as per the previous videos. So pretty much what that really means is that we have to reorganize them. So what we're kind of going to do is we're going to take out all these packs on the side here. We're going to lay them out on the floor, and now there's 20 packs obviously all in series. So what we're going to do is we're going to combine them together to give us 10 packs of 64P. So that means we're taking two of these packs, sticking them together, and that'll give us 64P, and then what we'll do is we'll add on to that to give us 80P, and that'll give us 10 kilowatt hours to be able to put into the battery box and connect to the hybrid SolarX inverter. And what it will mean is that stage 2 later on will mean that we'll leave this other bank in here for now, and we'll come back to that later after we've got the battery box and the hybrid inverter and everything running on 48 volts. And also we're going to be 10 kilowatts over there, and we'll have 5 kilowatts just sitting here. Obviously I'm still working on the inverter, the good time inverter that failed as per a couple of videos ago, so I'm still working on that. So right now these cells are just, everything's turned off, nothing's actually happening. They're not fully charged. I've kind of left it not fully charged, but anyway, what I'll do is let's pull them out, put them on the floor, and let's have a look. So this is now how it's looking, all on the floor on a piece of wood that I just had lying around. Actually worked out pretty good. So I've actually gone through all of these and I can't find a single fuse that is blown, which is really good and quite impressive. So these have been running obviously for the last year or so since my first videos on this. Some packs have been put together at the very start, and obviously as the process has moved along, my soldering and bits and pieces has got better and better, and looking at some of the cells closer you can kind of see that. But either way, this is kind of how it looks after it's all pulled out. If we flick back across to the Powerwall where it was, or the rack, it looks a bit empty. So yeah, they're all on the floor here. Now some of you smart cookies would have already realized that what I said before is I've got 20 packs here and we need to combine them together. What that means is obviously we'll only have 10, and that's 4 short from 14S. So 14S is 48 volts, and that's exactly what we need to fit into our battery box to connect to our SolarX hybrid. So what that means is actually, just before I actually say that, the next thing is that the last two packs here, some of you might have already noticed that these last two are longer. Now obviously I didn't have enough 2000 milliamp hours cells and above at the time, so I soldered up some 1800 to 2000s and just made the pack slightly longer. So that was the advantage with obviously my setup, is that you can obviously have the packs as long as you like. So that's what I did. So for the last two there, these have been obviously in operation as well for the last year, and they performed very well. So all I did was obviously added a few more cells, I think 4 cells to the end, I haven't counted it, but somewhere like that, and that's obviously done the trick. So that's really good. However, we're not going to use these last 2 packs on our when we reconfigure all these, and when we put it into the battery box we're going to leave those out, and we're going to come up with something else. So what that leaves us with is obviously 9 packs when they're put together, And let me just quickly rearrange these. Right, so now just reorganizing those and taking those two other packs out, what we end up with two packs, what we end up with nine packs grouped together. So this is around 64p. Obviously I've just put them side by side, and what we're going to do is we're going to connect them together. So we're going to join these two together, and these will give us a block of 64. It's also going to mean we've got double positives, one coming out from one end, and double negatives using XT60 connectors, and obviously easy enough power for 50 volts, or easy enough wire size and connector capacity to run 50 amps, no issues at all. Remembering that these packs were capable of easily 32 amps, so putting them together is going to really help with running 50 amps plus going forwards. Now obviously we've got our packs are only 64 p. That's a bit of a problem, so I've come up with a solution for that. Dun, da, da. So what are these? Well, these are groups of 20p, and using exactly the same concept as what we've got over here. So what we're going to, so rather than obviously pulling apart all these packs and reorganizing them and making them all one big plastic joined together, that's just a heck of a lot of work, and it's just not needed. So what we're going to do is, these packs here are 20p, and what I've made them, and I've made them exactly the same way as obviously these other ones, and that's to keep everything consistent. So what I've got here is I've got enough packs of these to fit on the ends of these. So what's going to happen is that this is going to come up to here, and it's going to be like that, obviously much closer together. So let me just work some magic and make that happen on each of these. Dun, 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 once again. So this is how it's going to look. Now obviously these things are going to be stuck together, they're not going to be so far apart obviously, but what it means is that now we've got a pack of 64p plus a pack of 20p. So we're going to join those together for around 84p. Now the advantage of that is that, remembering that these cells here have already been in use for the last year or so, so by having an extra 4 cells per pack, that's my theory is going to help the overall capacity to make sure that we do have at least 10 kilowatt hours throughout this whole bank once they're all put in series. So it's looking pretty impressive obviously now that things are slowly coming together on this piece of wood here. But again, we've only got 9 packs here. We don't exactly have enough. Obviously what we need is 14s. So once again, I have a plan for that. So dun, 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 we've got an extra bunch here. So we've got 5 more. So that gives us 14s. So what I've done here is that, obviously preempting this over the last few weeks, and I tell you what, I really hate soldering now. So these are 80p packs, exactly the same design as these. I've kept it consistent obviously because these are all going to be in series, so I didn't want to change up things and make things completely different. That's what I'll potentially do on other packs, but for now let's keep things the same. So what we've got, double positives coming off the side, double negatives at the bottom. We've got our pure copper strip down the end. This one here I actually did slightly differently. This uses 3 bus bars in the middle, but all the rest use just 2 because 2 is all I need. But this one here I kind of went a little bit overkill, but hey. So what that means is that now well, these are all put together. This is pretty much just one big pack, so all of these are exactly the same. I've built these over the last few weeks of cells that I've put together over the last 6 months, knowing that I'm going to need the cells for this. So now what we've got is we've got 14s, 80p and 84p, so with roughly around the same capacity as these ones here, because these are obviously much newer cells than these ones here that have been in use for the last year. We're not going to exactly know until we get everything in series and connected up and checking the voltages and things like that, but in theory this should work. So really the next step is for me to put these packs together and put them together and then connect the ends onto them to make this one big pack. So that's really the next step, so I'll just do some soldering. So this is how it's looking now after putting the 20p pack with the 64p pack. I had to charge that up. The next thing I had to do was, because there was a slight imbalance between the 64p's and the new 5 that I made of 80p's, I had to charge up the 80p's a little bit more and then put them all into balance. So what I've done is I've gone down the same idea as I did 8 months ago, where I've used a long nickel metal strip run along the positive, the negative at the bottom there. I've also done so it's pegged on the positive and the negative, and then and then just left that for pretty much 2 days now. So it's actually been 2 days. So what that's meant is now it's all in balance. I've just unplugged that little last pack because I just used it for the last video, and so now that they're all in balance, they're all ready to be put back into, or to be able to actually put into the battery box outside, and then obviously after that would be to connect it up to the SolarX hybrid inverter. So this has been very successful. Obviously it's all in balance. This is what 10 kilowatt hours looks like, all lined up, and I'm really excited actually to move on to the next step, and to get them into the battery box so I can actually put the car away now. So yeah, see you guys in the next video. Subscribe if you haven't subscribed, and I'll see you on the next one. Thanks.